Let's now take a look at how we go about solving logarithms with fractional bases. If a fraction has an exponent, then distribute the exponent to both the numerator and the denominator. So let's say we have a logarithm with a base of a over b, and the argument is a over b to a power of y. Why is this? Well, if this logarithm is equal to a power of y, then if we take this base and raise it to a power of y, this will give us an argument of a over b to a power of y. And if a fraction is raised to an exponent, we then want to distribute this y to both the numerator and the denominator. And when we do so, we will wind up with a to a power of y and b to a power of y. Now, why is this important? We're going to review two different scenarios of logarithms with a fractional base. The first one will look like this. You'll have a base that is a fraction, such as 2/3. You'll raise this to a power, such as this one, 2, and that will give you an argument of 2/3 raised to a power of 2. And then when you distribute this 2 to both the numerator and the denominator, that will give you 2 squared, which is 4, over 3 squared, which is 9. So we see log of base 2/3 of 4/9 is equal to 2. And this shows us that if we have a base that is a fraction and the logarithm has an argument that is a fraction, when this is positive, that lets us know that the base and the argument have fractions that are aligned. 2 squared gives us 4, and 3 squared gives us 9. And as a result, the logarithm is positive. So we are going to walk through an example like this one. And in the next part of the chapter, we'll see situations in which the base and the argument have fractions that are not aligned. So let's walk through an example together. Let's say you're asked to evaluate a log of base 3/4 of 27/64. What is this equal to? Whenever we have a base that is a fraction, we want to go ahead and set the logarithm equal to y. So we get log of base 3/4 of 27/64 is equal to y. And now we want to convert the function to exponential form. So we take our base 3/4 and raise it to a power of y and set that equal to the fraction 27/64. And now once we do this, we want to distribute the exponent y to the numerator and the denominator, giving us 3 to a power of y over 4 to a power of y is equal to 27/64. And now at this point, we want to check the alignment of the fractions. So we take a look at the numerator, and we have 3 to a power of y is equal to 27. And we ask ourselves, can we multiply 3 times itself and eventually get 27? And the answer is yes. And if we take a look at the denominator, we have 4 to a power of y is equal to 64. So we ask ourselves, can we multiply 4 times itself and eventually get 64? And the answer is yes. So since both are possible, that lets us know that these fractions are properly aligned. So what do we do here? Step 5, we want to use the numerators or the denominators to solve for y. So I'll show you both to show you that in both situations, y will have the same exact value. So we'll begin by using the numerators to solve for y. So that would be 3 to a power of y is equal to 27. And now we want to multiply the base 3 times itself until it equals 27. So that would be 3 times 3, which is 9, and 9 times 3 is 27. So we see that we multiply the base 3 times itself 3 different times to get 27, showing us that y is equal to 3. We'll get the same value for y if you choose to use the denominators instead. So 4 to a power of y is equal to 64. So we want to multiply 4 times itself until we get 64. 4 times 4 is 16, and 16 times 4 is 64. So we see that we multiply the base 4 times itself 3 times to get 64. So in both cases, we see that y is equal to 3, letting us know that a log of base 3/4 of 27/64 is equal to 3. So that is how we go about evaluating a logarithm with a fractional base that is aligned with the argument. Let's now have you try a few practice questions. Question number 1. Evaluate the log of a base of 3/2 of 9/4. Question number 2. Evaluate the log of a base of 2/5 of 8/125. And question number 3. Evaluate the log of a base of 4/3 of 64/27. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We want to evaluate the log of a base of 3/2 of 9/4. When we have a base that is a fraction, the first step is to set the function equal to y. And now step 2, we want to convert the function to exponential form. So we take our base 3/2, raise it to a power of y, and set that equal to the argument 9/4. And now this power y, we want to distribute it to the numerator and the denominator. So we'll wind up with 3 to a power of y over 2 to a power of y. And that's equal to 9/4. And once we distribute the exponent, we want to check the alignment of the fractions. So in our numerator, we have 3 to a power of y is equal to 9. And that checks out because this base can wind up with the product of 9. And for our denominators, we have 2 to a power of y is equal to 4. And that checks out because this base of 2 can wind up providing a product of 4. So now step 5, we want to use the numerators or the denominators to solve for y. So if we use the numerators, we get 3 to a power of y is equal to 9. And now we want to multiply the base 3 times itself until we get 9. And 3 times 3 is equal to 9. So we have to multiply the base times itself 2 times, showing us y is equal to 2. Or if you chose to use the denominators instead, you would have gotten 2 to a power of y is equal to 4. And 2 times 2 is equal to 4. Again, showing us that you multiply the base 2 times, letting us know y is equal to 2. So the answer to question number 1 is a log of base 3/2 of 9/4 is equal to 2. So that is the answer to question number 1. Let's now have a look at question number 2. We want to evaluate the log of a base of 2/5 of 8/125. Since we have a base that is a fraction, step 1 is to set the function equal to y. And now step 2, we want to convert the function to exponential form. So we take our base of 2/5, raise it to a power of y, and set that equal to the argument 8/125. And now we want to distribute the exponent y to the numerator and the denominator, which would give us 2 to a power of y over 5 to a power of y. And that's equal to 8/125. And once we distribute the exponent, we want to check the alignment of the fractions. our numerator, we have 2 to a power of y is equal to 8. That checks out since this base can multiply times itself to get 8. In our denominators, we have 5 to a power of y is equal to 125. And that checks out because this base of 5 can be multiplied times itself to get 125. So once we check the alignment of the fraction, step 5 is to use the numerators or the denominators to solve for y. If you chose to use the numerators, you would have gotten 2 to a power of y is equal to 8. And 2 times 2 times 2 is equal to 8, showing us that y is equal to 3. Or if you chose to use the denominator instead, you got 5 to a power of y is equal to 125, showing us 5 times 5 times 5 is equal to 125, which means y is equal to 3. So in both cases, we see we have to multiply the base 3 times, letting us know y is 3. So the answer to question number 2 is a log of base 2/5 of 8 over 125 is equal to 3. So that is the answer to question number 2. Let's now have a look at question number 3. We're given log of base 4/3 of 64/27. And since our base is a fraction, we want to go ahead and set the function equal to y for step 1. And then the second step is to convert this function to exponential form. So we take our base 4/3, raise it to a power of y, and set that equal to the argument 64/27. And once we do this, step 3 is to distribute the exponent y to the numerator and the denominator, which would give us 4 to a power of y over 3 to a power of y, and that is equal to 64 over 27. And once we distribute that exponent, we now want to check the alignment of the fractions. So if we take a look at our numerators, we get 4 to a power of y is equal to 64, and that is fine, since 4 can be multiplied times itself to get 64. And for our denominators, we have 3 to a power of y is equal to 27. And that checks out since the base 3 can be multiplied times itself to get 27. So since the fractions are properly aligned, step 5 is to use the numerators or the denominators to solve for y. If you chose to use the numerators, you got 4 to a power of y is equal to 64. And 4 can be multiplied times itself 3 times to get 64, letting us know that y is equal to 3. Or if you use the denominators instead, you got 3 to a power of y is equal to 27. And 3 can be multiplied times itself 3 times to get 27, also showing that y is equal to 3. So this lets us know that the answer to question number 3 is a log of base 4/3 of 64 over 27 is equal to 3.